Hello, further mathematicians. This is the refinement of the Specimen 2020 paper, which is non-calculator. Question 1. Circle the value of m. I know that y is the same as y to the power of 1, so index laws tell me my numerator is y to the 6 plus 1 is y to the 7 over y to the m is equal to y to the 4, and I know that I subtract the powers when I'm dividing, so this is going to need to be 3. Part B, work out the value of n. I know that these two are going to add together to make 5, so n plus 5 is equal to 5, which means that n is going to equal 0. Let's see. I know that these multiply together and these multiply together and they are equal. So I've got 5p is equal to 2 times 6. So 5p is equal to 12. So p is equal to 12 fifths. You would get 1 mark if you had this and full marks for 12 fifths. Or if you've got 2.4 or 2 and 2 fifths, that's also that. Question 2, solve. I'm going to cube both sides first of all. So 7x subtract 13 is equal to 2 cubed is 8. And then adding 13, 7x is equal to 21. And dividing by 3, x is equal to, dividing by 7, x is equal to 3. You'd get 1 mark if you had this line and full marks for 3. Question 3, work out the value of a and b such that the left-hand side is identical to the right-hand side. Okay, I'm going to start by expanding the bracket. So I'll have 6ax subtract 3a plus 4ax plus 20 is identical to 60x plus b. What I'm going to do now is compare the coefficients. So I'm going to start with comparing the coefficients of x. So on the left-hand side, I've got 6a, lots of x. And then I've also got plus 4a, lots of x. So 6a plus 4a, lots of x, is identical to 60. So that's 10a is identical to 60, so a must equal 6. So a is 6. And then I'm going to do the same thing comparing the constants on the left-hand side and on the right-hand side. So on the left-hand side, I've got negative 3a plus 20. So comparing the constants, negative 3a plus 20 is identical to, and on the right-hand side, I've got positive b. So it's identical to b. I've just worked out that a is 6. So negative 3 lots of 6 plus 20 is equal to b. So negative 18 plus 20 equals b. So 2 is equal to b. You'd get 1 mark if you'd expanded the left-hand side. You would get 1 mark for forming an equation in x. And then you would get 1 mark for each of these. Question 4. ABC is a straight line with AB to BC is 5 to 2. AB to BC is 5 to 2, okay. Work out the coordinates of C. I'm going to split this into changes in Y and changes in X. And I'm going to split those changes in Y and X in the ratio 2 to 5 or 5 to 2. So this is 5, this is 2. I'm going to start with the change in x. So I'm looking at the x coordinates from 3 to 5, from 3 along to 5. I've jumped along by 2. So I've got for the x, I've got a ratio of 5 to 2, and that first part 5 is equivalent to 2. To go from 5 to 2, I'm essentially dividing by 5 and multiplying by 2. Dividing by 5 and multiplying by 2. So I'm going to do the same on this side. Dividing by 5, which gets me 2 fifths, and then multiplying by 2, which gets me 4 fifths. So this is 2, and this must be 4 fifths. Or I might, because I see decimals, I might write that as a decimal, 0.8. So 0.8. which means I'm going along 0.8 from 5. So the x coordinate of C is going to be 5 plus 0.8, which gives me 5.8. That kind of looks about right. This is 3, 5, 5.8. I think that feels not too wrong. And now I'm going to do the same in the y's. So this change, I'm going from a 7 to a 5.5, which means I'm going down by, from 7 to 5.5, I'm going down by 1.5. So this is 1.5, and that's my sort of 5 bit of the ratio. And I want to work out what this is, and that's the 2 bit of the ratio. So for the y's, I've got the ratio of 5 to 2. The 5 bit is equivalent to 1.5, and I want to work out what the 2 bit is. To go from 5 to 1.5, I might actually go via 0.5 to 1.5. So I want to go from 5 to 1.5. I don't have my calculator, so I'm looking for ways to do it without. From 5 to 0.5, I'm dividing by 10, and then 0.5 to 1.5, I'm multiplying by 3. So I'm going to do the same on this side. 2 divided by 10 gets me 0.2, and then multiplied by 3 gets me 0.6. So this little change is going to be 0.6. That means I need to go from my y coordinate, 5.5, down 0.6. So my y coordinate is going to be 5.5 subtract 0.6, which gets me 4.9. 5.8 and then 4.9. 4.9. You would get 1 mark for showing up. You needed to get up to this line actually, showing 5 plus 0.8, the equivalent of that. And then 1 mark for getting up to this line in the y coordinate, 5.5 subtract 0.6, and then 1 mark for each of these values. Question 5. Y equals 2x to the 10 subtract 3 over x squared. Work out dy by dx. I can see they want me to differentiate. This term is differentiation ready. It's in the form something, x to the something. This term is not differentiation ready. So I'm just going to work with the negative 3 over x squared to make it differentiation ready. I'm going to write that as negative 3 over 1 times 1 over x squared, which is negative 3 times x to the negative 2. Okay, it's now differentiation ready. So I've got y equals 2x to the 10, subtract 3x to the negative 2, which means dy by dx is going to be multiplied by the old power, 20, reduce the power by 1, multiplied by the old power, positive 6, reduce the power by 1, negative 2 subtract 1 is negative 3. So my final answer is 20x to the 9 plus 6x to the negative 3. You would get 1 mark if you'd written negative 3x to the negative 2. 1 mark for either of these values. So if you've got 20x to the 9, that's 1 mark, and 1 mark for both of the values correct. Question 6, simplify fully. I can see I've got an algebraic fraction, so my first step is to see if I can factorize. The numerator I can see I can factorize a 5xy, and that will leave me with 3x subtract y. And the denominator I can see I can factorize a 4, and that will leave me with, sorry, I can factorize a 4, and that will leave me with 3x subtract y. And then my 3x subtract y's can cancel. So I'm left with 5xy over 4. You get 1 mark for factorising the numerator, 1 mark for factorising the denominator, and 4 marks for this as your final answer. Question 7. ABCD is a rhombus with side length 8 and angle ABC 60 degrees. Work out the area of the rhombus. Give your answer in the form a root b centimetres squared, where a and b are integers. I know a rhombus it's like a square that has been pushed over, which means all the sides are the same length. So this length is 8. these lengths are also 8. So a rhombus, all sides are the same, all sides are equal in a rhombus. Area of a rhombus. I'm not sure how to work out the area of a rhombus, but I can see I could maybe split it into two triangles. I know how to find the area of triangles. I'm going to split it this way so that I've got a triangle with two lengths and an angle, as opposed to this way where I could work out this angle, but this is going to be simpler. And I'm going to see if I can work out the area of this triangle. I know to find the area of a triangle, I do a half AB sine C. So that's a half times 8 times 8 times sine of 60 is √3/2. I'm looking to simplify. A half times 8, that's going to give me 4 times 8 times √3/2. I'm looking to simplify. I can divide the 8 by 2, so that's 4 times 4 times √3, which is going to leave me with 16 √3 as my final answer. I'm happy because that looks like this form that they've asked for. You'd get 1 mark. Oh, sorry, I've missed something. That's the area of one triangle, but it was asking for the area of the rhombus, which is, this is another, a rhombus also has opposite angles are equal. This is another 8, 60, 8 triangle. So altogether I've got 32 √3. Sorry, that's my final answer. I'm happy because that looks in this form. You would get 1 mark for a half times 8 times 8 times sine 60. So if you'd written, let's change those to 8s. That's 1 mark. You would get 1 mark for multiplying your area by 2, and then full marks for 32 √3 as your final answer. Question 8. The curve y equals 2x cubed minus 3x squared minus 12x plus 6 has a maximum point at -113 and a minimum at 2, -14. It intersects the y-axis at n. The curve crosses the x-axis at 3 distinct points. Sketch the curve. Label L, M, and N on your sketch. I'm going to start by thinking about the shape. This is a positive cubic, which means it's got this kind of shape. It tells me it has a maximum at -113, so I'm going to plot that on or sketch it on. So -1 is going to be somewhere around here. 13. Don't worry too much about the scale. It just needs to be in the right quadrant. And it tells me to label L, so that is L. So I'm going to put an L there. M is 2, -14. So 2, -14 means that M is going to be down here. And then N is where it intersects the y-axis. Intersects the y-axis, I can actually read from this form. The y-axis is a bit like the c in y equals mx plus c. It's just the constant on its own. So this is my y-intercept, which is n. So 6 is where it intercepts the y-axis. So that's going to be below 13, somewhere down here. And that is going to be n. Okay, I'm going to just think about what would happen if I joined those points. Could I get, if I went like this, could I get something that looks like this, the kind of positive cubic shape that I'm looking for? Yeah, I think I could. Am I going to get 3 distinct points where it crosses the x-axis? Yeah, I think I'll get one like over here, one kind of over here, and then one over here. So that feels like it's going to work. So I'm now going to connect those points. Obviously use a pencil. I'm doing it in pencil, you can see clearly. So like this, so there's my maximum. There's my y-intercept. There's my minimum. And there's my third point of intersection with the x-axis. You would get 1 mark if you showed that it was crossing at 6 and that was n. You would get 2 marks for showing that you had the correct shape and that it crossed the x-axis either once or twice, and then 3 marks for all of those values and that shape as I've shown. Question 9. A, B, C, and D are points on a circle. BCA is X, okay, yep. ACD is 2X, okay. CAD is 3X, yep. And CAB is 4X. Okay, I've got all that information already on. Prove that that AC is a diameter. Whenever I have a proof question, I need to make sure that I'm giving reasons. So I'm going to list reasons whenever I can probably see that it's circle theorems or maybe just angles in triangles, those kinds of things. I'm going to make sure that I give my reason each time. Okay, to show that AC is a diameter, I think what I could do is show that I've got angle in a semicircle. If I could show that this was 90 degrees, then that would have shown that this is the diameter because I've got an angle in a semicircle. So I'm going to see if I can show that this is 90 degrees or that this is 90 degrees, that either of those are 90 degrees. What could I start with? I could start with, well, I see this cyclic quadrilateral and I can see two opposite angles in that cyclic quadrilateral. So what I'm going to do is start by saying that 3x is equal to 180 subtract, and this is 7x here, 7x. I might just write on a full 3x so that it's clear how I got that, just so they don't think I'm referring to that 3x. 7x there. 3x is equal to 180 subtract 7x, and my reason is opposite angles in a cyclic quadrilateral sum to 180 degrees. Okay, I'm going to see if I can solve from here. So adding 7x on both sides, 10x is equal to 180, dividing by 10, x is equal to 18. Okay, now that I've got x, I think I could work out the size of these angles. So this angle is going to be 18, and this angle is going to be 4 lots of 18, which is 72. And I could work out this angle by doing 180 subtract 18 plus 72. So I'm going to do 18 plus 72, that's equal to 90. 180 subtract 90 is equal to 90. And the reason that I did 180 subtract 90 is because I knew angles in a triangle sum to 180. So I'm going to write that reason. Angles in a triangle sum to 180 degrees. And I've therefore shown that angle CBA is 90 degrees. My final step is just to wrap up my proof. So angle CBA is 90 degrees. And I'm then going to say angle in a semicircle means that angle in a semicircle is 90 degrees. Therefore, CA or AC must be a diameter. Must be a diameter. Okay, you would get 1 mark for forming an equation. It might be like this. I'm going to show you the marks because there's a few different ways you could have got it. But if you've done a similar method to me, this is going to get you your first mark. You would get 1 mark for solving to find x is 18. You would get 1 mark for working out that the size of angle CBA or CDA is 90 degrees. And then your final mark is... Oh, sorry, these require you to have the reasons. So this 90 degree, you can only get this mark if you've got... Oh, and sorry, the final mark is for your reasons. So your reasons linked to your working. So all of these reasons linked to your working will get you the final mark. I'll just show you the marks in case you followed a different method. So you might have added together. Actually, that is the same as the method I used. Yeah, I think there is. I think it's pretty much the method I did. Looks like there's not another alternative way to do it. Yeah. Okay, question 10. fx is 9x over 2 to the negative 1. Gx is this, so p is a constant. Given that f of a third equals g of a third, work out the value of p. Okay, I'm going to start by seeing if I can work out f of 1/3, which means I'm substituting 1/3 into f of x. So that's going to be 9 lots of a third over 2 to the negative 1. 9 times a third is 9 over 3 is 3. So 3 over 2 to the negative 1. Negative power means I take the reciprocal, and if I've got a fraction, that means I reciprocate the fraction, I flip the fraction. So that's 2/3. And that is equal to g of 1/3. So g of 1/3 is going to be substituting 1/3 into g of x. So 1 subtract p lots of 1/3 to the power of 3. So I know that this is equal to 2/3. So 1 subtract p times 1/3 cubed equal to 2/3. And I'm going to see if I can solve from here. So I'm going to square first of all. 1 subtract p times a third cubed equals, I square this, I square the numerator and the denominator, so 4/9. I'm then going to add the p times a third cubed onto the right hand side. So I've got 1 is equal to 4/9 plus p times a third cubed, and then subtract 4/9 on both sides. 1 subtract 4/9 is going to give me 5/9. So 5/9 is equal to p times 1/3 cubed. I'm going to cube this fraction now. So 5/9 is equal to p times 1 over 27. So 5/9 is equal to p over 27. And I'm then going to cross multiply. So I'm going to have 5 times 27 is equal to 9 times p. From here, I'm actually not going to do 5 times 27. What I'm going to do is divide by 9. Just I'm looking for ways to be efficient with my working. Dividing by 9 is going to give me, because 27 is nice to divide by 9, so 5 times 3 is equal to p, so 15 is equal to p. You would get 1 mark for this line, 1 mark for working out f of a third is 2/3, 1 mark for equating that to g of 1/3, 1 mark for getting up to this line, and then full marks for 15 as your final answer. Question 11. A circle centre C touches the y-axis at the point 0, 2. Yep. The line y equals k intersects the circle at the points 1k and 5k. Work out the equation of the circle. Know the equation of a circle has the form x minus a all squared plus y minus b all squared is equal to r squared, where ab is the centre. I'm going to see if I can work out the centre. I can see that the y coordinate is just going to be along, straight along from here. If it's these have the same y coordinates, this is going to also have the same y coordinate. It's going to be parallel to this line. So the y coordinate is going to be 2. I'm going to see if I can work out the x coordinate of here. The x coordinate is actually going to be equidistant between these 2 points. Because this is a horizontal line, the x coordinate is going to be bang slap in the middle. So it's going to be between 1 and 5. So the x coordinate is going to be 3, which means my equation is going to be x subtract 3 all squared plus y subtract 2 all squared is equal to, I'm now going to see if I can find the radius. To work out the radius, if I could work out the distance between the centre and one of these points, I'd be able to work out the radius. In fact, actually, easier to focus on this line. This is going to be much easier to work out the radius. The radius is from the centre to the circumference. Here's a point on the circumference, and I've got both of the coordinates for that. So that's going to be much easier. And because it's horizontal, it's an even nicer one to find the radius for. The radius is just going to be that distance, which is, because the y coordinates are the same, it's just that change in the horizontal, in the x coordinates. So from 0 to 3, the radius is just 3. So 3 squared, which gives me 9. So my final answer being x minus 3 all squared plus y minus 2 all squared is equal to 9. You would get 1 mark if you had the x coordinate of 3, 1 mark for the y coordinate of 2, and then full marks for this as your final answer. Question 12. AB is 4, AC is 7, cos of x is negative 2/7. Work out the length of BC. So that's this length. This is making me think of cosine rule for sides. I'm going to write my formula. A squared equals b squared plus c squared minus 2bc cos A, and substitute in where this is going to be angle A, this is side A, this is going to be B and C. So x squared is equal to 7 squared plus 4 squared minus 2 times 7 times 4 times, it told me that cos of A, cos of x, is negative 2/7. So times by negative 2/7. Okay, I'm going to see if I can solve from here. So x squared is 49 plus 16. And I'm going to try to be efficient with my working here. I can see I'm multiplying by 7 and then I'm dividing by 7. So those 7s can actually cancel. I can see I've got a negative multiplied by a negative. So this whole term, this is one term, is going to become positive. So I'm going to have positive 2 times 4 times 2 is 16. So x squared is 49 plus 32. So x squared is 81. Oh, that's nice. I've got a nice square number. So x is, it's a length, so it has to be positive 9, not plus or minus 9, positive 9. It's happy because they didn't say exact value or leave your answer as a cert. So I'm kind of maybe expecting to get a nice whole number as my answer. You would get 1 mark for this line. You would get 1 mark for getting up to x squared equals 81, and 4 marks for 9 as your final answer. 13. Rearrange to make w the subject. I'm going to start by multiplying by the denominator. So that will leave me with tw cubed minus 2t is equal to 3w cubed plus a. I'm then going to try and get my w's onto one side and my non-w terms onto the other side. So I'm going to get my w's onto the left-hand side. Doesn't really matter, but that will just leave me with less negatives if I get w's on the left and non-w terms on the right. So I'm going to subtract 3w cubed. So tw cubed subtract 3w cubed, and I'm going to add 2t is equal to 2t plus a. Factorising out w cubed, and then dividing through by that factor. And then finally cube rooting. Making sure that I include w in my answer. I'll lose a mark if a w is not in my answer. And making sure my cube root extends all the way over that fraction. You would get 1 mark for this line. You would get 1 mark for getting up to this factorised line, and then 4 marks for this. Oh wow, 5 marks. Sorry, I was looking at the 3rd, 4th and 5th. Sorry, 1 mark for if you'd just shown you a multiplying. That is going to get you a mark. 2nd mark is for this line. 3rd mark is for getting your w's on one side and your non-w's on the other. 4th mark is for factorising, and then 5th and final mark is for this. Very generous. Okay, question 14. Rationalise and simplify. You can see I've got a binomial denominator. I'm going to multiply by the conjugate is root 3 minus 1 over root 3 minus 1. I'm going to do my numerator first. Root 3 subtract 7 times root 3 minus 1 is going to give me 3 minus root 3 minus 7 root 3 plus 7 gives me 10 subtract 8 root 3. And then my denominator, root 3 plus 1 times root 3 minus 1. It's going to multiply to give me 3 plus root 3 minus root 3 minus 1. My root 3's cancel, that leaves me with just 2. So I've got 10 minus 8 root 3 all over 2, which can simplify to 5 minus 4 root 3. You would get 1 mark for multiplying by the conjugate. You would get 1 mark for a denominator of 2. 1 mark for a numerator of, it doesn't need to be simplified, so if you've got this line, that is 1 mark, and then full marks for this as your final answer. 15. Point A lies on the curve y equals x squared plus 5x plus 8. The x-coordinate of A is negative 4. Show that the equation of the normal to the curve is 3y equals x plus 16. Equation of a normal is very much making me think of differentiating. So I'm going to start by differentiating. So dy by dx would be 2x plus 5. And then I'm going to substitute in this x-coordinate to work out what's the gradient of the curve when x is 4. So at x equals, negative 4, when x is negative 4, y by dx is 2 of negative 4 plus 5, which is negative 8 plus 5, which is negative 3. So the gradient of the curve is negative 3. A normal is perpendicular to a curve. So that means the gradient of the normal is going to be positive 1/3, the negative reciprocal. So the gradient of the normal is positive 1/3. So I know that my equation of my normal is y is positive 1/3 x plus c. I now need to work out c, and I'm going to need an xy coordinate to do that. I've got the x coordinate, but I need the y coordinate. I'm going to use this to work out y. So y is equal to, when x is negative 4, y is equal to negative 4 squared plus 5 lots of negative 4 plus 8, which is positive 16 subtract 20 plus 8, which is negative 4 plus 8, which is 4. Which tells me that when x is negative 4, y is 4. So the point negative 4, 4 lies on my curve. I can now substitute that into my y equals mx plus c to work out c. So I've got 4 equals 1/3 times negative 4 plus c. So 4 equals negative 4/3 plus c. Adding 4/3 on both sides, I'm going to write this as 16 over 4. Adding 4/3 on both sides is going to give me 20. Oh, what have I done? Sorry. Let's go back. I want to write it as a denominator of 3. So I'm going to write it as 12 over 3. Now I can add 4/3 on both sides. Gives me 16 over 3 is equal to c. So y is equal to, sub it back into this line, 1/3 x plus 16 over 3. It asked me to show this, and I'm not quite there. It's looking pretty good. I've got a 16 and I've got 3 bits of that. I think what they've done is multiplied by 3. So I'm now going to multiply by 3 to all terms. It leaves me as 3y equals x plus 16. 3y equals x plus 16. Yes, great. That's the thing that they asked me to show. You'd get 1 mark for substituting negative 4 into your equation for y. You'd get 1 mark for differentiating. You'd get 1 mark for substituting negative 4 into your differential. You would get 1 mark for finding the gradient is positive 1/3. And then this is often the case with show that questions. The final mark, the fifth and final mark, is quite a lot of work. All of this to kind of justify the thing they've asked you to show is how we pick up our final mark. Question 15b. The normal at A also intersects the curve at B. Work out the x-coordinate of B. Okay, so the normal at A, so I'm going to write down the equation of that. The normal at A was 3y equals x plus 16. Intersects the curve. The equation of the curve was this, x squared, y equals x squared plus 5x plus 8. Equals x squared plus 5x plus 8. When I've got a coordinate geometry question like this that's talking about intersection of curves or intersection of a curve and a line, essentially I need to solve these equations simultaneously to find the point of intersection. So I'm going to solve these equations simultaneously to find the point of intersection. I've got a quadratic, which means I'm going to need to use substitution to solve this. I've got y as the subject here, so what I could actually do is I could substitute this for y. I could substitute that for y. That I think is going to be easier than the other option is you could make x the subject of the linear equation and substitute it into this, but that's going to involve kind of squaring that. It's probably going to be a little bit more work. So instead of making x the subject and substituting, I've got y as the subject, so I can replace or substitute that y with this. So I've got 3 lots of x squared plus 5x plus 8 is equal to x plus 16. Now expand 3x squared plus 15x plus 24 equals x plus 16. I've got a quadratic, so I'm going to get everything onto one side, make it equal to 0. So 3x squared subtracting x plus 14x subtracting 16 plus 8 is equal to 0. And from here, I'm going to try to factorize. So choose the AC method. 3 times 8, 24. Two numbers that multiply to make 24 and add to make 14 are 12 and 2. So I've got 3x squared plus 12x plus 2x plus 8 is 3x lots of x plus 4. I know this needs to be an x plus 4, and I'm going to need a plus 2 to get 2x plus 8. So 3x plus 2 lots of x plus 4 is equal to 0. So x equals negative 2/3, or x is negative 4. It just wanted the x-coordinate, and it wanted the x-coordinate at B. The x-coordinate at B, so the normal at A also intersects the curve at B. A had the x-coordinate negative 4, so I'm happy. I've kind of solved and I've got a negative 4, which means I've probably got done the right thing. But it's asking for the B coordinate, so this is the point that they want. So my final answer is going to be negative 2/3. You would get 1 mark for this line. You would get 1 mark for getting it equal to 0. 1 mark for factorising. You might have used the formula, but factorising is probably easier without a calculator. And then 4 marks for negative 2/3 as your final answer. Question 16. The coefficient of the x to the 4 term in the expansion 2x plus a to the 6 is 60. Work out the possible values of a, because I'm expecting more than 1. This is very much making me think of Pascal's triangle, binomial expansion. So I'm going to write my triangle up to the 6th row. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. I've got to my 6th row, the one that's got a 6 after the 1. So now I'm going to set up my table. Give myself lots of space. 1, 6, 15, 20, 15, 6, 1. And then I'm going to need my 2x, making sure I've got the whole 2x that each time is raised to the power of, starting with the highest power is going to be 6. And then in descending as 2x to the 5, 2x to the 4. And I'm actually going to stop here because it was asking about the x to the 4 term. So I actually only need this column, I don't need to fill in my whole table. I've got my x to the 4, so I can now just zoom in on this column. So I'm going to work out for this row up to this term. So that's my a. So I've got a to the 0, a to the 1, a squared. Zooming in on this column, I need to now multiply these together. So I've got 15 times 2x to the 4 times a squared. And it told me that that was equal to 60. The coefficient of x to the 4 is 60. So that's equal to 60 x to the 4. So I've got 15 times 2 to the 4 is 2 times 2 times 2 times 2 is 4 times 4 is 16. X to the 4 times a squared equals 60x to the 4. I can get rid of my x to the 4s. So I've got 15 times 16 times a squared is equal to 60. I'm actually going to look to be really efficient with my working here. And I could divide through by 15 on both sides rather than, I don't really want to do 15 times 16. So instead I'm going to divide by 15 on both sides. So I'll be left with 16 a squared is equal to 60 divided by 15 is 4. And then dividing by 16 on both sides, a squared is 4 over 16, which is a quarter. A squared is a quarter, which means square root. Two possible values. They wanted values, so a is the positive or negative square root of a quarter, which is a half. So a is plus or minus a half. You would get 1 mark for this left-hand side. You would get 1 mark for making it equal to 60. You would get 1 mark for getting up to a squared equals a quarter. And full marks, you must have plus or negative a half, or a half and negative a half. That's your final answer. Question 17, solve the simultaneous equations. I'm looking to eliminate a variable, and I'm looking for any variable that has the same coefficient so that I don't have to do any multiplying. And I can see that equation 1, I'm going to label them. There's a few options. Equation 1 and 3 have the same c coefficient. Equation 2 and 3 have the same b. So there's 2 options. I'm going to go for 1 and 3. So I'm going to write what I'm doing so the examiner is really, I'm not making their life more difficult than it needs to be. So I'm adding together. I've got c's are the same and they've got different signs. So I'm going to add together equation 1 and equation 3. So 2a plus b minus c is equal to 8, and 6a plus 3b plus c is equal to 0. I'm adding them together. That leaves me with 8a plus 4b is equal to 8. And I'm going to look to simplify wherever I can, just to give myself less chance of making arithmetic slips. I can see this equation can be divided by 4 to give me 2a plus b is equal to 2. Okay, I've got one equation in a and b that's nice and simple. I'm going to see if I can get another equation in a and b. So that means I need to eliminate c from another equation. I'm going to go for, we could do either the first two or the second two equations. It doesn't really make any difference. I'm going to go for the first two. So that means I need those c coefficients to be the same, which means I'm going to multiply that top equation by 2. I'm going to label my work. Multiplying equation 1 by 2 is going to leave me with 4a plus 2b subtract 2c is equal to 16. I'm going to write equation 2 underneath, labeling my work. 4a subtract 3b subtract 2c is equal to -9. I've got the same sign for c's, which means I'm going to subtract to eliminate c. Labeling and writing my operation. Subtracting means that the 4a's are going to cancel. Yes, haven't made a slip there. The 4a's are going to cancel, that's nice. So I've got 2b, being really careful with negatives, subtract -3b. 2b subtract -3b, which leaves me with 5b. My c's cancel, is equal to 16 subtract -9, being really careful with my negatives, is 25. Okay, nice. I haven't got something like 5b equals 13. I've got 5b equals a nice multiple of 5. So I'm quite happy that I've not made an arithmetic slip up until this point. Dividing by 5, b is equal to 5. Nice whole numbers means I'm probably on the right tracks. I'm now going to substitute in to find a and c. I'll go for this equation first to find a. So 2 lots of a plus 5 equals 2. So 2 lots of a is equal to -3. So a is -3 over 2. I've got a fraction or a decimal, but it's not a really nasty one. So I'm hoping that that is okay. I've got a nice, kind of a nice fraction or a nice decimal. Finally, I'm going to see if I can find c now. It doesn't matter which equation I pick, but I'll go for nice small numbers. So I'll go for that top equation. So labeling my work, I'm substituting into equation 1. So I've got 2 lots of a, so 2 lots of -3 over 2, plus b, 5, subtract c is equal to 8. The 2's can cancel, so -3 plus 5 subtract c equals 8. So 2 minus c is equal to 8. I'm going to add c on both sides. So 2 is equal to 8 plus c, and subtract 8 on both sides. -6 equals c. Again, I've got a nice integer for c. So I'm kind of feeling confident that I haven't made any careless slips. Yes, that is looking good. So a is -3 over 2, b is 5, and c is -6. You would get 1 mark if you showed that you were adding together 2 equations to eliminate a variable. So if you did the same method as me, 1 mark for this line, 1 mark for 1 mark for doing the same, eliminating the same variable from another pair of equations. So if you did the same method as me, 1 mark when you get to this line, 1 mark for solving your equation, so getting up to here, and then 1 mark for substituting into one of your equations, so getting up to here, and then full marks for all 3 values of a, b, and c being correct. Question 18. Solve x to the -2/3 equals 12 and 1/4. I'm going to write this, I feel like writing this as an improper fraction might be a good idea. So x to the -2/3 is equal to, multiplying by 4, 48, plus 1, 49 over 4. I'm feeling good about that because those are square numbers, and I think I'm going to square root at some point. I see this squaring happening on the left-hand side. The first thing I'm going to do is actually get rid of that, doesn't matter the order, but I'm going to get rid of that negative. I know negative means reciprocal, so I'm going to take the reciprocal, which when I've got a fraction means reciprocate the fraction, means flip the fraction. So x to the 2/3 is equal to 4 over 49. I'm now going to need to get rid of that cube root and get rid of that squaring. I'm going to get rid of the squaring first, because to get rid of squaring I square root, which means I'm making stuff small. I want to make stuff small before I make stuff big. I'd rather not cube 49. Square rooting on both sides is going to give me x to the 3rd is equal to 2/7. Good, nice whole numbers. And then finally cubing on both sides gives me x equals 8. 7 cubed, I'm not too sure, but I know 7 squared is 49, so I need to do 49 multiplied by 7 gives me 63, 28, 34, 343. 8 over 343. You would get 1 mark for, if you'd written this as your first step, that would get you a mark. 1 mark for getting to this line, if that was the path you took, and then full marks for 8 over 343. Question 19. fx is this. Use differentiation to show that fx is an increasing function for all values of x. An increasing function means it's got a positive gradient, so it means dy by dx is greater than 0. So the first thing I'm going to do is find dy by dx. So that would be 6x squared minus 24x plus 25. I'm trying to show that this is always positive. To do that, we have to complete the square. To show that a quadratic is always positive, we have to complete the square. So I'm going to try and complete the square with this. I've got a coefficient of x squared, so the first thing I'm going to do is factorise it out of the first two terms. So I've got 6 lots of x squared minus 4x. I'll leave the plus 25 on the outside. I'm now going to complete the square with these two terms. So I've got 6 lots of, and then use a double bracket, x subtract 2 all squared, subtract 4, plus 25. I'm going to multiply out the 6 with the negative 4 so that I can get rid of one set of brackets. So 6 lots of x subtract 2 all squared, subtract 24 plus 25, and collect my like terms. 6 lots of x subtract 2 all squared plus 1. I'm trying to justify that this is always positive. Well, I know that x subtract 2 all squared is always going to be, the smallest it could be is 0, so it's always going to be greater than or equal to 0. So I'm going to state that x subtract 2 all squared is always greater than or equal to 0, which means 6 lots of that is going to be something greater than or equal to 0. So 6 lots of x subtract 2 all squared is always going to be greater than or equal to 0, which means if I add 1 to that, I'm going to have something that's greater than or equal to 1. So 6 lots of x minus 2 all squared plus 1 is going to be greater than or equal to 1. And anything greater than or equal to 1 is going to have to be positive, is always going to be positive. So positive. And if I've got a positive gradient, that means I've got an increasing function. So my final step is just to justify the thing they asked for, which wasn't to justify dy dx was greater than 0. It was actually to justify that's an increasing function. So I'm going to say, therefore, fx always increasing. You would get 1 mark if you had differentiated. You would get 1 mark for factorising out the 6. You would get 1 mark for getting up to this line. And then you would get full marks for this last bit. So completed square form and then a justification that this is always positive, therefore f of x is always increasing. Question 20. Show that 2 cos squared theta is identical to 2 subtract 2 sine squared theta. I'm going to start with the left-hand side. I can see cos squareds and sine squareds. I'm thinking about my trig identity, the one that's cos squared plus sine squared, or sine squared plus cos squared, is 1. I'm going to let the right-hand side guide me, and I see sine squareds. I've got cos squared, so I'm going to think about making cos squared the subject so that I can rewrite the left-hand side in terms of sine squareds. So cos squared is 1 subtract sine squared. So I could write this left-hand side as 2 lots of 1 subtract sine squared, which is, if I multiply that out, 2 subtract 2 sine squared, and then just write it in full, 2 subtract 2 sine squared theta. It's only 1 mark that, so that it's only sort of 1 step really. You'd get 1 mark, it's just 1 mark. You'd get 1 mark for showing this whole thing. You must have this line, and then just so long as you've shown that that expands to the thing they've asked for, that is going to get you the mark. Part B, hence, which means I'm going to use my answer to part A. Solve 2 cos squared theta plus 3 sine theta equals 3. They're saying hence, and I see that 2 cos squared theta up here, so they want me to write that. They're pretty much telling me to write that as 2 subtract 2 sine squared. So I've got 2 subtract 2 sine squared theta plus 3 sine theta is equal to 3. I'm going to write that in shorthand. So 2 subtract 2s squared plus 3s equals 3. And then I've got a quadratic. I want to make that s squared term positive. So I'm actually going to get all of the terms onto the right-hand side and make it equal to 0. So subtracting 2, adding 2 sine squared, and end up with 0 equals 2 sine squared subtract 3 sine plus 1. I'm going to write it this way around just because I prefer having it on the left, and then see if I can solve this. I can see I've got a quadratic, and I'm going to see if I can factorise. So I'm looking for 2 numbers that multiply to give 2 and add to give -3, or -2 and -1. So 2 sine squared minus 2 sine minus 1 sine plus 1 equals 0. Factorising 2 sine lots of sine minus 1. I know I need a sine minus 1, so I'm going to need a minus 1 here. So 2 sine minus 1 lots of sine minus 1, which means sine is 1/2 and sine is equal to 1. I'm going to put these s's back as sine thetas. Sine theta is 1/2, sine theta is 1, and solve from here. Sine theta is 1/2. Well, that comes from my trig exact values, which tell me that my principal angle is 30 degrees. Sine of 30 is 1/2. It's asking for all values between 0 and 180. So I'm going to draw my graph of sine, which looks like this. And 180 degrees is here. So I actually am only allowed values in this range. 30 degrees, I'm going to draw it quite close to the origin. If it's sort of in the middle, we get a bit confused about whether we add or subtract. But if I draw it quite low down or quite high up, it's usually less confusing about which order to add and subtract. So I'm going to draw it quite low down. So there's my 30-degree angle, which is when sine theta. This is theta, this is sine theta, when sine theta is 1/2. I can see I've got another angle over here, and I can see this little jump is the same as this little jump, and those little jumps are both 30. So to work out this value, I need to do 180 subtract 30, which gives me 150 degrees. So I'm going to have 30 degrees, 150 degrees, and then sine theta equals 1. Well, 1 is up here, so I'm just going to use my graph. When sine theta is 1, I'm here, which is 90 degrees. And 90 degrees, my final answer. You would get 1 mark for getting up to this line. You would get 1 mark for factorising. You would get 1 mark for sine theta is 1/2 or sine theta is 1. And then full marks for all 3 of these answers with no additional answers. That's the end of the paper.